Hello and welcome to the introduction of a video course called Math for 3D/Games Programmers. This course is intended for anyone who wants to learn really solid fundamentals of mathematics used in video games and 3D applications. In this short presentation, we will skim through the contents of this course, as well as talk about tools that we'll use. We will also discuss certain mathematical notations that are used in the actual chapters. More detailed information about the course's contents can be found on its website over here, and here is also a link to my personal homepage. Okay, but who am I actually that I have credentials to talk about mathematics used in 3D games? I'm a software engineer who has worked professionally in the video games industry for well over 10 years now, mostly as an engine/graphics programmer. I've worked at companies like NVIDIA, id Software, CD Projekt Red, and Flying Wild Hog, among others. Here again is a link to my personal website where you can find out more about me, my portfolio, and find links to my LinkedIn and MobyGames profiles. Here we have the high-level look at the table of contents of the course. A detailed table of contents can be found on the course's website, so under this link over here. The course is roughly split into 3 parts: analytic geometry, those first 4 chapters, followed by linear algebra, the next 3 chapters, and finally calculus, the last 2 chapters. The first part of this course, so those first 4 chapters, are available for free on the course's website. We start with the basics, that is trigonometry, which you are likely already familiar with. But even if you are, this chapter has some useful trigonometry-based algorithms which you might not be familiar with. Next are complex numbers. This is not something you find often in video games math courses, but we discuss it as it constitutes fundamentals for concepts that we'll cover in Chapter 7. They will also make a surprising cameo in Chapter 8, so it's definitely worth knowing your complex numbers. Then we talk about vectors, which is something you find covered everywhere. Apart from standard vectors discussion, we will also present certain useful algorithms here. Chapter 4 uses information from chapters 1 to 3 to mathematically describe the most important geometrical objects that we use in 3D programming. In chapters 5 and 6, we discuss matrices and transforms, or transformations, which we use for manipulating objects in 3D space. This topic is so large and important, but it is split into 2 chapters. In the next chapter, we cover quaternions, which just like matrices are used to manipulate objects in 3D space, but which exhibit certain very useful properties that matrices do not have. Finally, in chapters 8 and 9, we discuss derivatives and integrals. Many math courses for programmers don't include these in their curriculums, which is a great shame, as knowing derivatives and integrals can elevate your math skills to a whole new level. Please visit the course's website for a detailed description of all of the course's chapters. Let's now discuss what tools we will be using throughout this course. Our most important tool is the Unity engine. I chose it because it's easy to use, it is ubiquitous, and free, at least for things that we will use it for. Many of the examples will use Xenon, which is a helper library for drawing 2D and 3D shapes, which I wrote specifically for this course. Here you can see a code snippet responsible for drawing the image to the right, this one, which presents just a coordinate system with a few points and lines connecting these points to the origin. The sole purpose of the library is to facilitate operations like that. Our next tool is Wolfram Alpha. Wolfram is an answer engine, a bit like Google or ChatGPT, but is tailored to giving answers to math and science questions. We will use it many times to solve some more complex equations that will pop up here and there. Certain equations or system of equations we will be dealing with are complex enough that performing calculations manually by hand would be very, very cumbersome. Wolfram Alpha will save us a lot of work and time here. Here on the screen you can see how Wolfram solves a very complicated equation over here, but I assure you that it can do much more. On one occasion we will run a very short program written in Octave. Octave, which is sort of a free version of MATLAB, is a scientific programming language / platform It has lots of libraries and utilities for performing mathematical operations. Think of it as something in between Wolfram Alpha and your usual everyday programming language. In this screenshot, here you can see how Octave is used to calculate the product of two matrices. A few words on the so-called sum operator or sum notation. We use this notation to more compactly describe a sum of elements. Let's say that we have a series of elements defined like this here. We can write it more concisely using the sum operator here. This sum is basically just a mathematical loop that starts here at I equals 1 and goes up to I equal n. So in this case, it is going from the value of 1 to the value of n. And inside this loop, we are evaluating this term over here, and we are adding it to the overall sum for each value of I. In this case, this term will give us values from this series above. So for example, for I equal 1, we get here 2 times 1, which is 2, minus 1 is 1. So we've got 1 over here. Then if I is equal to, we've got 2 times 2, that is 4, minus 1, it's 3. So we've got 3 over here. So this sum here perfectly corresponds to this series defined here. Note that this n up here in this sum operator notation is not the count of iterations, but the end value for I. So if, for example, we make I equal 3 instead of 1, and we still have n over here, then in total this loop will go 2 elements less, because we will be going from 3 to n instead of from 1 to n. So it will be 2 elements less, because this over here is the end index for I and not the count of iterations. Here is a list of references. It is basically a list of books that I used to learn many of the things present in this course. All of these resources I highly recommend if you want to expand your understanding about the subjects that are talked about here. The first two, this one and this one, are great classic books about math used for 3D games development. The third one is a fantastic general math textbook from which you can learn a lot on your own. It is a much better read than your average math textbook. Highly recommend it. Not all of the resources are given here. Other, more specialized ones will be given as we go along.